Hi, today I want to speak about materialized views in QuestDB. You might be familiar with the term materialized view from other databases. A materialized view is used to pre-calculate the results of queries that are costly to execute. They take too many resources or too much time. When you create a materialized view, the results of the query are stored on a backend table, so whenever you query that view, you are not executing a real query, you are reading from the pre-calculated results. But unlike in other databases, it will be always kept up to date automatically whenever you have new data on your table. When you're working with time series, your tables are going to be ever growing. And very often, you are getting data at a very high frequency. But after a while, when your data is historical, whatever that means for you, it might be after a few days, it might be after a few weeks, it might be after a few months. Maybe you don't want to remove your original data, but you want to downsample the data and delete the original to save on storage. You can also use materialized views for that use case in QuestDB. On this dashboard, I have 6 panels. The 2 at the top are coming directly from the base table without any view, but the 2 candle bars, the mid price and the volume weighted average, they can actually from materialized views. And this dashboard at the moment is refreshing every 250 milliseconds. And if I change the filters here, you can see all the views, all the charts refresh pretty much instantly. This candle chart is actually displaying the last month of data. This one is displaying the last 5 days, and still, when I change to any value, they refresh pretty much instantly. It's not a huge data set. I have only, let me just check how much data. I'm simulating some securities data here. So I have a table with some master data from Treasury securities, and then I have some prices and some trades. So let me just show you how much data I have right now here. I have only about not even 40 million rows of prices, and I have 260 million rows with trades, which is not huge, but it's already big enough that it could get slow. These are some of the queries that I'm running on the dashboard that you see. The first 2 panels, the panels on top, they are not using the materialized view. I'm just getting in real time the latest values for the QSIP and the latest security terms, and just refreshing in real time. This query is pretty fast as it is. If I execute, you can see the query executes in microseconds. The second query that I have is the candle chart, the open, high, low and close chart. And this is what I'm doing. I'm just getting the first price, the maximum price, minimum price, the last price, and the total volume. And I'm doing candles of 1 minute here. So if I don't have any filters, it takes more than 1.5 seconds to execute, which is not ideal if you want to refresh a panel in real time. Of course, this is because I'm querying the whole data set. So when I'm filtering only one symbol and only for 1 day of data, for example, it is way faster, but still it takes about 15 milliseconds, 20 milliseconds to execute this query on the server. Then I have this volume weighted average, which is a query in which first I'm just selecting some totals with a sample by for a particular symbol, and then I'm running 2 window functions to get the volume weighted average. And again, this query is actually quite fast, but it's a kind of complex query, and I think it will benefit from materializing the results. And the last query I have, this is the mid price query here. The last query is doing a join between 2 tables. It's taking the trades table and the price table, and it's calculating some averages just for the mid price, but it's actually a join with a sample by. With materialized views, I'm going to be able to materialize these results to make it way faster. So Creating a materialized view in QuestDB is actually pretty simple. You can see here, this is the query I'm using to create the candle charts. So I'm selecting the timestamp, the symbol, the first price, the highest price, minimum price, the closing price, and the amount, and I'm sampling by a 1 minute interval. So to create a materialized view, all I have to do is this: create the view, if not exists optionally. This is the name of the view, and just like that, my view is created. In my case, it was already created, but if not, this view will be created. And I can see the original table, and you see we have 261 million rows. And if I check the materialized view, since I'm materializing at 1 minute intervals for each symbol, here we have not even a million rows. So in this case, I have a table which is 260 times smaller. So of course it's going to be way faster to query when I'm going to be running my dashboards or whichever query I'm going to be using with these bars. If I check, we have a new function in QuestDB, which is called materialized views, where you can see the metadata from your materialized views. And I can see here, if I check here my view, the one I just created, I can see the base table is the trades table. And this means every time there is new data, a new transaction on the trades table, automatically the view is going to be refreshed. So if you check here, every time I click on select, I can see the last refresh of the query has incremented. But if you notice, the time between the start of the refresh and the end of the refresh is actually in the same second. It's just milliseconds or even microseconds apart in some cases. How is this possible? Well, the way we work in QuestDB, when we are refreshing a view incrementally, we are not executing the whole query on the whole data set. QuestDB is smart enough, so we build our incremental materialized views, so whenever there is a new transaction, QuestDB is going to check the data only around the rows you are ingesting. So we don't have to execute a very costly query whenever we have to materialize the view, unlike other databases. That's why we can be very fast refreshing the views. The downside of this approach is that there are some things that you shouldn't do on a materialized view. You can check the documentation, but for example, if we use a window function on a materialized view, or if you are doing an as-of join, you need to be very careful, because since we are going to be checking automatically only the rows around the transactions you are ingesting, you might be missing data. So if you check the documentation, you will see we tell you to avoid window functions, or we tell you to avoid many as-of joins in materialized views. And I'll tell you later the workaround how you can do this using materialized views and still have window functions and so on. So for now, let me just go and create the rest of my views. I'm going to create a materialized views for my prices table. So my prices table, I'm going to just store the average price at 1 minute interval, so I can join the table later with the other one I have. And again, in the prices table, I have 37 million rows, and now I have under a million row. So again, more than almost 40 times actually a smaller table. It should be way faster to query. And again, if I check from this view, I can see that pretty much all the time the view is refreshing automatically. So something I want to show you now is not only how fast the queries are executing, because right now on my server I'm just executing these queries on my demo server, so you know they are going to be pretty fast, but I want to show you the CPU they are using. So let me just show you for a second. This is the CPU of my machine here. I have 16 CPUs, and right now they are not doing much. I mean, I have just the dashboard, so you know they are just continuously using some power. Look what happens if I execute my OHLC query without using a view. If I run this query, the CPUs, all the CPUs on my machine, they go for a few moments to 70 something, 80% CPU. So my server at this point is not only that the query is taking 1.5 seconds to execute, is that also the CPUs are using a lot of power. If I filter only for 1 day of data, of course it will be nicer, it will be faster, but still I can see they jump every time I execute to about 30 something percent of CPU. So they're using 15% more of what they are using, like, only with the dashboard. Let's now check what happens if I select directly from my view. This is the view I created. First, execution is just 3 milliseconds. And if you compare to running the query for just yesterday, it was 200 milliseconds. If I execute the query for the whole dataset, for the whole month of data I have in the demo, it was over 1.5 seconds. But even just for yesterday, it was 200 milliseconds. If I execute for the whole dataset on my OHLC materialized view, it takes 2 milliseconds. And if you look at the CPUs, there is no difference. I mean, the CPUs don't have to do anything. Yeah, it's a 1% increase on the CPU, but you don't notice. That's pretty much the thing. It's only one CPU is just temporarily using a slightly more power. Even when I'm checking for yesterday, like, you cannot really see anything happening here in the CPUs. So with the same machine, you can run much more queries and they also return way faster. So let me just again show you this dashboard. So this query here is just this chart here, sorry, is just reading data from the materialized view without any further aggregation. This other chart here is running the data, again with no aggregation, but I'm querying the whole month of data. And a whole month of data without the aggregation, it was 1.5 seconds. Here we can refresh first time, like, every second, and the CPU is not doing anything at all. This query here is a bit more interesting to me because in this one, I'm going to make this a bit bigger. In this one, I'm actually doing a join. I'm taking the 1 minute table for the trades. I'm joining as of join with the 1 minute view for the prices. And then I take in the maximum and minimum price and the average price from the other table. So basically here, I'm downsampling in 5 minutes intervals. So basically here, what I'm running is a join. And as I showed you earlier on this query, this join was actually quite slow to execute. If I'm running the last 5 days of data, it's it's half a second, over half a second to execute in many cases. But here, if I'm executing on materialized view, it's immediate. So I can execute this query many times a second, and I don't have any latency, any lag at all. The last query, for me, it's a bit more interesting. In this query, I want to show you how you can use window functions on top of a materialized view. Let me show you this query. I'm going to the query inspector so I can copy this into the web interface. Here it is. So what I'm doing in this query, I told you earlier that it's not a good idea to use a materialized view in QuestDB with window functions or with some as of joins, because since we are only focusing on the data around the transaction we are ingesting, if your window function is defining a window frame which goes way in the past, it could be missing the rows and give you an incomplete wrong result. So what you can do is what we are doing here. I'm running a query on top of my materialized data. In this case, we saw the original table had 250 million rows and the materialized table had only 1 million rows. So we are querying over a much smaller table. We are filtering for today and for a QSIP, so we are only reading a few rows. And on top of that data from the raw table, I'm going to be running the window function. So the overquery, the window function, rather than materializing the result of the window function, I materialize the raw data I need to use, and with that, I can run a window function on top of the smaller materialized data, and it's already pretty fast. So with that trick, you can create financial indicators where you need complex joins or window functions, and still being able to use materialized views. But sometimes you don't need all that power. I mean, sometimes you don't need your view to materialize that frequently every time there is a transaction. For example, in this dashboard here, I have one of my charts, this panel here, is displaying only one candle per day. So I have the open, high, low, and close for every day. In this particular case, I don't need my view to refresh constantly. It's wasteful to refresh for each transaction if I'm not going to be using intraday data, or even for intraday, you want maybe to refresh just a few times a day because you don't need low latency. In this other panel, I'm showing the last hour of candle bars with 1 minute interval. So this one can be interesting to refresh constantly, but this other to the right doesn't make sense. Something you can do in QuestDB, you can create materialized views that refresh on a timer. Let me format this a bit nicer. Okay, so it looks pretty similar to what we did before. The difference here is you can create a materialized view in which you define when it's going to materialize. In my case, I'm saying that this view is going to refresh once per hour. I could say once every 12 hours, once every day. It really depends how fresh you want to have the data. But the important thing here, everything else is the same, by the way. You only change that you put here the interval for the refresh. So once you create the table, in this case, my view already exists, so I have an error. I can add this. So once you create the table, you can already, of course, check data from this table. I have only 2,500 rows because it's only one per day and per QSIP. But if I check select from materialize views, you will see that this view is not refreshing automatically, where view name is HLC 1 day. So this here, you see whenever I refresh, it doesn't change. The timestamp is always the same for the refresh. Something actually when you create a table, materialized view with timer refresh, if you query the materialized view immediately after, you will see there is no data. But you can force refresh at any point in time. And you can also do this, by the way, with a view which is incremental. So when you refresh, if I check now here the timestamp, you can see now is 5:54 UTC. If I refresh again, now it's 5:54 and 29 seconds. Refresh again, and you see it's changing. But if I don't refresh manually, it will refresh only once every hour. So you can have the balance between how fresh is the data and how much extra process your server needs to do. Because every time you update a materialized view, the server needs to run a query. It's going to be typically a small query. It's going to be only around the transaction that you are ingesting data, but still, the server needs to query data and ingest every time you refresh. So if you don't need to refresh data constantly, it's a good idea to create views on a timer. And the last thing I wanted to show you today about materialized views is that you can combine views with TTL, with time to live. So you can have a life cycle strategy for storage management. For example, here I have my my table, the prices table. If I check my table, I can see the first price is from the 1st of May. If I check the view in which the materialized view, which is referencing for this table, the first entry is also from the 1st of May. Something I can do, I can change my prices table and I can tell to keep only 2 days of data. So now, when I check my prices table, I can see the first date available. It's the end of the month actually, not the first day of the month, but just 2 days ago. However, if I check my materialized view, my view is still keeping all the data since the beginning of the month, since the first time I created materialized query. And of course, this query is still refreshing, it's still getting new data. And something I didn't tell you earlier, but actually you can see here, is that when I create a view, I can create a view based on a table like this one, or I can create a view which is based on another view. When I created the timer view, I'm not reading from the raw table, I'm actually reading from the materialized table I already have for 1 minute bars. So if you want, you can create views that are cascading, that materialize based on another view. That way, when you materialize the data, it's actually way faster to read from the materialized view than for the original table. And you can also add TTL, time to live expiration, if you want, into your views. And that's pretty much it. I hope you found interesting what you can do with materialized views in QuestDB. And if you have any questions, just let me know in the video. Just jump into our Slack channel, into our documentation, where you have plenty of examples how to create materialized views. And stay tuned, because we are going to be adding, now that we have the first release materialized view already out there, we are going to be adding new interesting things into materialized views. I tell you all about that in a few weeks. Have a good day.